All right, so let's take a look at this problem. Um, we want to do two things. We want to come up with a list of possible rational zeros, and then to use that list to actually solve this equation for rational solutions, for rational zeros that are also called roots. So it's in standard form, 5, 4, 3, 2, 1 constant. Um, let's look at the factors of our constant term. I'm going to look at the factors of 15, and there's a plus or minus in front of each one of these numbers. 1, 3, 5, and 15 are the numbers that divide 15. The leading coefficient is 1, which is pretty nice because now I'm supposed to create a fraction of a list of possible rational zeros to where this is my numerator for my list and this is my denominator, but it's so easy to divide by 1, and I'm not going to write that as a fraction. I'm not going to write 1 over 1 to 1 over 1. I'm not going to write 3 over 1, 5 over 1, 15 over 1. That later on we'll have to do that, because if this is a number that's different than 1, then we're going to have to divide by all this. But when we divide by 1, we just get these numbers back. So I just write it as 1, 3, 5, and 15. Now I don't know if any of these are actually solutions to this equation or not. I can look at it and tell you for certain that the positive numbers aren't, because if we're adding all of these terms together, I know that a whole list of positive numbers is never going to add up to 0. So when I start looking in this list for possible 0 remainders using the synthetic division, I'm going to start with negative numbers. So I've got 1, 5, 4, 20, 3, and 15. Now, I am trying not to make any errors, because that's not going to help you to watch me really make a lot of mistakes. So definitely this is not 0. So since I threw out positive 1 and now I'm throwing out negative 1, I know that's off the list. So let's check negative 3. Negative 78, negative 75. Definitely not 0. All right. So 3 and negative 3 are off the list. All right. So 1, negative 5, 0, 0, 4, negative 20, 0, 0, 3, negative 15. Hey, we found one. Okay. So now, sometimes you kind of say, well, so what? Now that I did that, what am I supposed to do with it? And this left-hand side, we can now take this expression and factor it into two expressions, where one of the factors, you have to change the sign, because if negative 5 is a 0 or a root to this equation, then x plus 5 is a factor. And since it started out to the 5th power, this is starting out to the 4th power. So I've got 1x to the 4th power. I don't have any x to the 3rd powers. Then I've got 4x squared. I don't have any x's. And then plus 3. Now, I know that most of you know how to factor this, and that's what I would normally do, but I'm just going to return to this list and show you Well, the list tells me, what does the list tell me? Well, 1 and 3, I can throw out 5 and 15 because I'm looking for numbers that divide 3, which is just 1 and 3, but we already checked -1 and -3, and we know that +1 and +3 don't do it. So I know that this produces no rational solutions. I can verify that, I guess, by using my own factoring skills and saying that I know that x squared times x squared is x to the fourth, and I know that 1 times 3 is 3, and 1 plus 3 is 4. And look, x squared is never going to equal -3, so that didn't provide a rational solution, and x squared is never going to equal -1. So, the theorem didn't lie to me. If there were zeros, they were going to be in the list, but there's not any. And this second term here, this x to the fourth, 4x squared plus 3, that by itself doesn't cross the x-axis. Now, because of this x plus 5, I know this original expression does, and I know this original expression crosses at -5. That -5 is my answer. That's the only rational solution. So I hope that helps. I hope that wasn't too long.